Hey, this is Kyle from essentialdeveloper.com. Today we are carrying on our discussion on software architecture, specifically on the iOS analytics architecture overview, answering the question on how to fix the common problem of premature abstraction. So to start off, what is architecture? MVC? MVVM? MVP? Well, not really. Those are architectural design patterns or guidelines. Architecture is more about structuring the intent of the system. And how so? First of all, understanding the domain problem and designing a good structure to solve that problem. And what is a good structure? Well, we're talking about software architecture. And software should be soft. Requirements are changing all the time. User interface changes. Business goals change. The client needs change. The market change. So the goal of a good software architecture is to structure the system to be soft while solving the domain problem. And what makes a system soft? Well, it must be flexible, maintainable, and scalable. And how can you validate if your system is soft? Well, some traits of good architecture are: you welcome requirement changes. You know how your boss always comes to you with new requirements and things change all the time. Well, that's normal in the business world, and our software needs to be adaptable. If it's hard for you to be changing the requirements all the time, that is a good indication that there is a problem with your architecture. Another trait of a good architecture is that it improves the estimation accuracy of the team, meaning that every time you have new requirements, it's much more clear to understand how much work that would take, and you can estimate much better. Another trait is it makes testing easier. Good architecture also allows you to develop independently, and that means that you can work in different tasks in the same project without getting in other people's way, without having a lot of merge conflict. That also means that you can deploy your components independently, you can test them in isolation and even in parallel, so you can really speed up your build times, your continuous integration, your continuous build. And if you sum all of those traits together, it is clear that that makes it much easier to maintain a fast and constant pace during the whole project lifecycle. I believe you've seen this before. When a project starts, productivity is very high, but as time passes, 1 year, 2 years, the productivity goes down drastically. But if you have a good architecture, you're going to maintain the same fast and constant pace you had in the beginning, even after 2, 3, 4, 10 years. So with that in mind, let's have a quick recap from the last episode and get to work. So in the previous episode, we analyzed the enum-based approach, and we noticed how enums create hard coupling, which makes it very hard to separate things in components. So we end up with this huge component where everything goes. And that violates the open-close principle. It makes independent development and deployment very hard. And changing software is based on breaking the code all the time, because it relies on compiler errors. Then we analyzed the struct-based approach, and we found out that since the name and metadata is quite generic, and they're using primitives, strings, it actually enables our architecture to be much more flexible, allows us to create components that can be developed independently. It's easier to add and remove components. You can test all of this in isolation, in parallel. You can have this in different projects. And with the use of extensions, we can have some nice APIs. They're very easy to use. But we also discussed how we can start having method name conflicts. So we also analyzed the protocol-based approach. And we noticed that it's very similar to the struct one, but it just helps us create much better organization for our project. And every component can decide how to implement the protocol, which is quite nice. You can create some tiny types with nice APIs. They're very easy to use as well. But architecture-wise, it's pretty much the same. It just allows you to organize your project better. But the protocol and the struct approach solves the high coupling problem. And at the end of the video, we discuss how the use of primitives here, it actually makes it very hard for implementations of the engine to log those events. Because one of the goals of this architecture was to allow any implementation for the engine, meaning we can have a custom one, we can use Firebase or Google Analytics, Crashlytics, or whatever. Or we could even combine more than one. But the problem is that every different framework, every different API requires different parameters. Firebase requires some fields to be integers. Maybe the Facebook SDK is going to require some data to be doubles for price, let's say. And we discussed how we can actually represent everything with strings, but the implementation of the engine would have to know the keys so we can convert it, which breaks the abstraction. And then the engine would have to know about keys, and keys are created in a lower level component. So that's not good. And all this problem was created because this abstraction was a premature abstraction. You need to have a more flexible architecture. Otherwise, every time there's a requirement change here, we might have to break this interface. And then everyone that talks to it or implements it needs to change. And this is not a good trait. This violates the number one good architecture trait: welcome requirement changes. And if you're breaking the interface all the time and adding more parameters here or adding if statements here to map keys and values, you're gonna start having a lot of conflict. And this is also gonna make your estimation not very accurate. And it's gonna make it very hard to maintain a fast and constant pace. Let's choose the logging view controller and let's implement a clean architecture with all the good traits we expect from it. Okay, let's go. So I think one of the biggest mistakes in there is that the view controllers need to tell the analytics when to log and what to log. And that's a responsibility that maybe shouldn't be there. So let's split this feature and let's create the architecture for the logging feature. And I think we can break it into business logic, UI and presentation, analytics, and frameworks. To fulfill the good architecture goals, the soft architecture, the flexible, maintainable, and scalable, we need to break down responsibilities and we need to find a way to connect them. And one of the most important things is that the business logic is the highest level. You don't want it depending on frameworks or the UI or analytics or databases or network. So in the logging feature, what is the common business logic? Well, there is validation for the fields and validate the response. That could be success or an error. And if it's an error, it needs to understand what happened and then pass this information along so we can present it in the UI. So let's add a use case with the logging business logic. So let's imagine a type or a function that is called logging, where you pass a name and a password. Right now, it doesn't matter who's going to call that. Once the validation happens and the communication with the server comes back, we need to delegate a message to say the result of that, success or failure. So let's add a delegate here, and it's just a protocol with two methods. Or it could be one method that passes a result type, or it could be just a closure. Right now, it doesn't matter that much. And if we think about it, the implementation of these business logic would be probably 20 lines of code. That's a very tiny component here with no external dependencies. Even though we need to talk to a network API at some point, we're also going to have a protocol that it talks to, and the implementation is probably going to be around frameworks or APIs here. But we are just analyzing the analytics side here, so let's focus. Okay, so next thing. Someone needs to call this method, and someone needs to implement this protocol. So there is communication in and out. We send a login command, and when there is a response, we send the result. So who implements this delegate? Well, it could be the view controller, but the view controller has a lot of responsibilities already. It needs to load the view, it needs to control the configuration of the view. So I think we can create something like a login presenter, and the login presenter can implement the protocol. As soon as the login result is defined, we call login succeeded with a user or an error. And since the login presenter implements that, we can then map the user or the error into a welcome message view model, in an error message view model, and pass it to the view controller through those display methods. And the login view controller just tells the view to render it accordingly. So who calls login with name and password? Well, there are some approaches that says the login view controller should tell the presenter and the presenter talks to the use case. I think that's fine, but I normally prefer to start with my view controller talking with the use case directly, just as a simple beginning, so we can see how the flow of the data flow happens. The view is gonna get a user event, like a button press, then it's gonna call the login method in the use case with the name and password. The use case is gonna talk to a service, generate a result, and pass it to the protocol. And the presenter implements the protocol, it's gonna get that and pass it to the view controller. And we create this nice cycle here. And we have this nice communication flow. Great. So I would say this presenter can be 15 lines of code. It's very tiny, simple. And the login view controller has a little bit more code because of the UI kit delegation. So it could be like 40 line of code. Maybe a little bit more, maybe less. Maybe you can use a framework here like Reactive Cocoa that's going to make these even less lines of code. So it's up to you. We're not defining implementations here. We're just separating components. Okay, so how does analytics fit here? Well, who's going to call the methods on the analytics module so things can be logged? Well, we can add a dependency to the view controller. There is the analytics engine or manager. And then we can make the view controller talk directly to this concrete type. And that works. But since we are using dependency injection here as well, and inversion of control, and we are delegating all the communication, what we can do is we can create a login analytics component here that actually also implement the login use case delegate, which means every time a message is sent through this protocol, the login analytics will get this message, and you can make the decision of sending these analytics to whatever framework it needs to, which means the important parts of your app, like the business logic or the user interface and the presentation, doesn't even need to know about analytics. This is the open-close principle in action. The login analytics can get this message and map this user to whatever format the frameworks it's going to talk to needs. And normally this will be, 15 lines of code, maybe 10. It's pretty much a mapping layer, delegating methods to a framework. So we could add like Crashlytics, can have custom analytics SDK, we can have Firebase at the same time, or we can have just one. And this analytics class or this analytics type will respond to the delegation by calling the appropriate methods in the frameworks. Because if you think about it, frameworks never depend on your project. You depend on frameworks. Frameworks are generic enough that they can be used in any project. So you want also to protect your business logic from those frameworks. So if you want to add a new framework, you just add it here. We may change the analytics, and that's it. If at some point we decide to not have analytics, or if we have an app that doesn't have analytics and then we decide that you want to have it, you can just add this new behavior, this new feature, without changing one line of code in your business logic layer or your UI or presentation layer. And also in the example showed last time, we also had an analytics event when the login view was presented. So to log that, we could also have a protocol or a closure, or we could even abstract this by using container view controllers. And the login analytics also implement this login view controller delegate. And every time the view controller is displayed, we can log this where we want. Another benefit of this is that by having this concrete layer that talks to frameworks, the UI, and implements those protocols, it means that if one of the business needs is that I just want to log errors in Crashlytics, this is very common to happen. I just want to log errors in Crashlytics, or I just want to log sales on Google Analytics because I have to trace those sales with my campaigns. We can do that very easily without changing any logic here. The login analytics type can just decide where to delegate this message to. So when you have like two types implementing the same protocol, or you have two functions that need to be passed as a closure, how can you do that? Well, a very simple approach is to just use composition. You can just compose things. You can have a generic function that composes functions. You can have a concrete type that implements the protocol and composes a bunch of other types that conform to this protocol, like a composite pattern. Where does this function live? Well, we can create down here like a compose logging use case delegate. Let's say it's 5 lines of code. So when you're creating your types, you're going to have some kind of factory, or you're going to have flows, or coordinators, or your dependency injection framework, and you have your app delegate. And if you look at these concrete factories and implementations and app delegates, this is the main module. This is the concrete module that starts up the application, sets up the dependencies correctly, and start running the app. This is also separate. You don't want any module depending on the main module. The main module is going to wire up all the objects together. So look at this. These types composes the implementations of the logging use case delegate. And of course it lives in main. So what we can do now is that we can draw lines separating those components, those layers, and we can look at them and analyze where the abstractions live. What is concrete? Where are the bottlenecks? If we create those lines, we can see how the UI and presentation depends on the business logic. The analytics is very concrete. It talks to frameworks, it implements business logic protocols, and UI presentation. And since analytics needs to extract a lot of data to your application, you need to have this trade-off of coupling here. Because every time you abstract this data to strings or try to make it too generic, it makes it very hard for you to log relevant business data, like prices, dates, and error types, and what caused the error, how long it took for the error to occur, the timeout, how much was the timeout. All those things are very important. And if you generalize too much with strings, the responsibility of mapping these is going to be maybe in the business logic or in the presentation, but analytics is more about logging. It's something that every application needs to have, but it shouldn't affect the overall intent of the application. So going back, frameworks don't depend on anyone. There's only arrows going inside the layer. The business logic also don't depend on any module, and that's good. There are no dependencies in UI, which means we can change the UI, we can present things differently, we can log things differently without affecting the core business logic. We can also change the presentation and the user interface without affecting analytics or the business logic or frameworks. So this is looking better. The only problem is that the more we add logging analytics, this logging analytics type might grow a lot. So what we can do is we can break it down into a Crashlytics wrapper that implements the logging use case protocol as well. So we can track the errors. We can have our custom analytics SDK wrapper that is super tiny as well. And it also logs success and failures. And it also implements the view controller delegate, so it knows when a view was displayed. But as you can see, the Crashlytics wrapper, it doesn't even implement the view controller delegate because it doesn't care. This is interface segregation. We just want to log errors in Crashlytics. And the Firebase one also just cares about the logging use case delegate. So this is a bit nicer. If we want to get rid of Firebase SDK, we could just remove this, like this. And this means just going to your project and deleting the files, and you don't have to change one line of code in your UI, presentation, or your business logic. So let's put this back. That's quite nice. We can very easily welcome requirement changes, meaning we can add new features, remove features, with minimal impact on the overall architecture of the system, which means it's much easier to welcome changes and much easier to estimate those changes. The changes are much more quantifiable. and definable. And by the way, where does MVVM and MVC and MVP and MV whatever lives? Right here in this layer. Look at this. This is where your MVC, MVVM and MVP lives. That's it. This tiny layer with roughly, let's say 50, 60 lines of code, can go up to 100. This is it. If we move the responsibility of validation to the view models or to the presenters, we are probably going to start having spaghetti code. And by breaking down those responsibilities, we found out that there are much more layers. There are layers that are more abstract and more independent, and there are layers that are more concrete and dependent. And there are things that are just tools or frameworks and delivery mechanisms like the UI. Another thing I changed in this diagram is that I created a protocol logging use case input. So if I'm testing the view controller, I can create a mock implementation of this, and I don't need to actually instantiate a real logging use case, which also makes it easier for us to change things in the business logic layer without breaking outside modules. It means we can completely rewrite this implementation, or we can swap them as needed without affecting external modules. And this could also be done with closures, of course, instead of a protocol. Just a matter of preference. Sometimes I use closure, sometimes I prefer to have a more descriptive protocol that creates some kind of documentation and contract, but that's pretty much it. Look how tiny those things are. Sometimes you look at those diagrams and you think, oh my god, this is so complex, there's so many things. But when you actually see the code, they're very, very tiny, contain functions or objects or structs. So the UI, let's say, can go from 50 to 100 lines of code. The business logic here, let's say it go from 20 to 45, 50 lines of code. And these analytic tiny wrappers can be like 5 lines of code each, maybe 10, 15. That's it. Maybe this fear or this feeling that those diagrams and these architecture things is bad and creates over-engineered solutions is just a lack of understanding of how to translate diagrams to actual code, and this is a skill we can master. So let's have a look at other ways of looking at this diagram. If we get rid of that protocol and we start using closures, we can create these implicit dependency. It means that this can still live in a different module without depending on this module. The factories will compose the method calls with the closures expected by the view controllers here. And I also added a logging view protocol so the presenter don't talk directly with concrete view controllers, which means for apps that need to deploy same functionality with different UI. Let's say you have a UI kit UI and you have an app kit UI, you have a watchOS UI, or even the iPad version of your app. It's so different from the iPhone that it's going to be easier to just have a different view controller. Then you can just implement the logging view protocol, and that's it. You reuse everything here. Everything here is going to be reused. You just have a different UI. That can also be combined and composed with the use case in the factories implicitly with closures. And if we have this view displayed also as closures, we can remove the direct dependency from the wrappers, and maybe that's good for you. I don't know, there are many ways to implement this. And the main point is that the architecture to be flexible, it needs to allow those different decisions to be made. It's very important to be able to maybe just forget about those defined types and just look at the arrows. The presentation just depends on the business logic. The UI just depends on the presentation. The analytics depends on the frameworks and the business logic, because it maps events to framework calls. And main is the most concrete layer that composes all the objects together, that wires up your functions or your objects. Doesn't matter if it's functional or object-oriented. Main is the place to add your factories and dependency injection code. And of course, you can break down main into different components as well. You can create reusable factories, abstract factories that can be reused as well. There are many things you can do if you understand architecture. Let's put this back here. And again, this might look scary, but the real implementation is very simple, and it fulfills all the requirements we need. It welcomes changes, it improves our estimation accuracy, it makes testing easier, it allows independent development and deployment and testing in isolation and parallel, and it makes it easier to maintain a fast and constant pace. And maybe for your specific domain problem, it might make sense to make your application very concrete. Who knows? But even if you decide to make it this high coupling, this decision needs to be made based on knowledge, not just on feeling. This decision needs to be very assertive, because the more concrete dependencies you talk to or depend on, the more you run the risk of getting broken when one of them changes. And this breaks the open-close principle. We want to be able to add functionality without breaking old functionalities. And of course, that's not 100% achievable, but at least we don't want it breaking all the time, because that also means you're breaking your tests all the time, and you're gonna hate your test suite. It just gets in the way. It just makes you slow. And it also prevents you from getting into nasty conflict when merging your code. So it's better to break down functionality and dependencies, making sure your components don't know more than they need to, and also don't depend on more dependencies that they need to depend on. And that makes your architecture flexible, maintainable, and scalable. So flexible, maintainable, and scalable architectures allow us to welcome requirement changes. They have a very clear intent, and they make it easier to measure and compare the costs of different parts of the system, even before implementing them. And this is the power of pretty much seeing the future before it happens. And of course, we don't want big upfront designs, but this took me, 15 minutes to do. Before you start working, you plan what you're gonna do. So I believe no one will say that those traits are not good traits for a software system. And this is what good architecture can provide. Well-organized architecture makes you go faster. Tests are easy to create and maintain, and they run fast. And the task to replace UI or databases or frameworks would be definable, quantifiable, and have a minimal impact on the application structure. Unfortunately, a lot of people make architecture decisions based on feeling. Well, this feels right, or I've been doing this for a long time. But if you're not achieving those good traits, if you ever say things like, I think we should rewrite the app, it just means that you are actually not achieving those business goals. Your architecture is not soft. And as we saw, like MVVM, MVP, MVC, they can be good design patterns and guidelines, but they have a place in your overall architecture. They are not your application architecture. They are your user interface design patterns. Because as we just saw for a simple feature, we already broke down responsibilities into much more than views, right? And there are so many apps out there. We cannot make an acronym that solves all the problem. I believe we need to have the knowledge to make those informed decisions. And we need the skills to be able to implement them as well. And the trade-offs is that you end up creating those tiny wrappers. You might create many of them. These ones are for analytics, but sometimes you can have them for separating your UI from the business logic or your presentation from the UI. So that's it. The trade-off is that you end up writing many small wrappers. that do very little delegate calls. And I don't see a problem with that, because the cost trade-off is between writing those wrappers and higher coupling. And high degree of coupling tends to create fragile, brittle code and can impede the good traits we just discussed about, like independent deployment and development. So in most cases, the costs of high-class coupling are too much, and the wrappers trade-off is easily the right choice. So we just had a look at some diagrams, and I received this question a lot. Are diagrams architecture? Well, no. They are just blueprints. Look at this. They are a visualization tool that just helps you make decisions and also communicate with your peers. So, do you have to write them all the time, or do I write them all the time? No. With time, you can learn how to make almost all those decisions directly. But they are always a very good tool for communication with your team, so everyone is aligned with the goals. And at the end of the day, the code will tell the truth. The code base is the ultimate architecture. The components dependency, the organization you create in your code base, the coupling you actually write in code is the architecture. And let's think about it. We can draw diagrams like we just did here. But if our implementation doesn't follow this blueprint, well, then our architecture is wrong. We cannot do anything with those blueprints apart from analyze them and use them as a tool to help us write the code. So the code is the architecture. How crazy is that? I used to think that the code is the product I am building, right? Because that's pretty much what we do. But now I like to think that the code is a communication tool as well. You write code to talk to other developers, to talk to yourself in the future. We want our code to be readable, right? And well structured. So, if the code is the architecture, are we all architects? Yeah. Somehow. What this really tells us is that since we all write code, we are all making architectural decisions all the time. And if they are not conscious decisions, there is a good chance we are not making the best decisions. And most teams nowadays don't even have a person known as the architect. And companies expect senior and lead developers to have those skills. This is very important. If you want to be a senior or a lead developer, this is very important. So our goal with this series is to help you improve your skills as a software architect, so you can start noticing when those unconscious architectural decisions based on feeling happen. We want our decisions to be conscious and based on knowledge, so we can be much more effective in achieving success. Knowledge enables you to have informed and productive conversations. So I suggest you to validate mainstream ideas with tests and experiments, get evidence and proof of what other people claim, even what I am claiming here right now. Just test it. Nothing is true just because someone says so. So get the freedom to choose for yourself. We are humans and we are not always right. So let's be open and make sure we find out our blind spots as soon as possible, so we can correct them and improve. So I hope you enjoyed this video and learned something today. And there is much more. So as always, don't forget to subscribe, like, share, and leave us a comment. Thanks for watching. Bye.